All right, we are at ATO Bit Lab today. Got another workshop here. This is our second workshop on kind of the Unix command line fundamentals, all that kind of stuff. So yeah, if you haven't seen the first one, you can check it out on the YouTube channel. or Twitch channel or anything like that. But yeah, otherwise, I'm just going to go ahead and pass it over to Bryan here to kick us off.
Thanks, Steve. Hey, everybody. I'm Bryan. I'm going to be leading everybody through some terminal commands and see if we can't continue to build out our skill set. So last time we went through a lot of the basics. So if you're
you might need to share your screen. With
yeah, sorry about that.
You're good.
I forgot that I killed that. Share screen.
We're all here in the lab projecting it onto a wall, so it's like giant and in our faces.
Nice. All right, cool. So yeah, so like Steven mentioned, there is a previous YouTube video. You can find a link to that in the meetup.com, or you can go to our YouTube channel, which should be ATL BitLab. And then you can get a fill in on what we covered, but a quick high level is, so if you go to this GitHub link, github.com/Nonni/Unix all caps, this is the content we went through last time that we're going to continue through. So the first time we got sucked into some details and talked a lot about like how Unix works and root structure and some basic commands, and then we ran out of time. So this time I'm going to get more into the activities of using the commands, and we're going to try and see if we can get through things like regular expression, basic and advanced Unix commands, and maybe into some shell scripting. So the first thing I want to cover is it's in the basic Unix for non-programmers. And so these first couple slides are you can ignore because this is like how to get into the Georgia State snowball. But first commands, I want to talk about this real quick. So these are kind of good to know. I don't really use Control U, but if you're running commands in the terminal, there it is, and you need to like interrupt it because you actually, for example, wrote a for loop that goes forever. Control C is kind of your best friend. Control Z will suspend the output, but it won't kill it. So you can Control Z and stop something, and then you can Control Z and start it again. And then these will S and Q I don't really use, but they will stop printing the screen. And so these are just good to keep in mind if you're doing something like. So it's just forever printing the word that you can do Control C to get out of it. All right, so some of the common utilities that we started to touch on last time, but we'll talk about, we'll go through now. So a good basic command to clear your screen would be clear, pretty straightforward. I don't know if clear everything that was previously, but you can still usually scroll up to see it all. And then listing files is kind of a bread and butter. So whenever you're in the terminal, you just need to figure out like, A, where are you? So pwd, print working directory, and if you look at this, it'll give you manual will give you all the information as well as like all these flags that you throw to give you different information about that. And then, so now that I know where I am in reference to the root, I'm in my home directory, the tilde drive, as you can see in the prompt. So this is username at computer name. This is the working directory, and this is the shell prompt, which means I'm in C shell. And so if I wanted to see what's in here, I can do ls, which stands for listing, list directory contents. And there's a lot of cool flags on this one that I use often. So I rarely ever use ls. I only use ll, just because I like to see a robust output of what I'm looking at in my directory. So ll stands for is an alias that I created, and most Linux systems out of the box in the profile or the -rc will have this commented out. And so if you, for example, are on a Linux machine and you do, well, maybe I'll stick with Vim because Alex did a Vim workshop instead of Nano. So if you Vim into your -rc, which I don't use bash, but so there's nothing really in here. But if you were on a Linux and that was the all right, cool. If you're on a Linux and bashrc your profile is your go-to, that's where you would find it. And so in my case, I'm using Z shell, so mine is a ZSHRC. And so in here I can see all of my aliases, right? So I have a lot of different aliases that I've created over time. And this is like my home. This is like the most powerful thing that I think I've set up since learning how to use Terminal, is learning how to alias things to make your life easier. So I alias all my git commands to things like st for git stash or push p, etc. And so in this case, like ll, I think is, let's see, how do I search in bin?
Slash. And it'd be like LL.
Nice.
And you just look through it.
N?
Yeah. Oh, there's a lot of LLs. You
Yeah.
You can do slash LL
Let's
equals.
do slash alias ll. Can I do that?
Yeah.
Nice. There you go. All right, so there's my LL alias. In Bash, RC for Linux and stuff would be a lot. It probably won't have this exact thing. It'll be something like ls-l, but I like to have the A so I can see what I've always called anonymous, but maybe they're not anonymous. They're dot files, which don't normally show up in shell when you do a listing. And so I realized, and some of these other things show you like how much space it takes. And I can't remember every single flag, but I realized at some point that those flags all spelled out Flask.
Oh, that's fun.
So I just rearranged them.
What's K?
Yeah, let's find out. That's a good question. God damn. All right, cool. So ls, man, ls.
The one I like is half, H-A-L-F.
Half.
Readable.
Did we talk about man pages last week?
I think high level, but yeah, so man is, I wonder if man has a man page. That's awesome. So if you type man, you'll see like the manual for the man command. And the man command is display online manual document pages. But you just remember it as a manual, right? The instruction manual for that command. And so if you, for example, look at this list in the slides and see, all right, ls, cat, more, like these are all utilities that are kind of like your base in Unix and Linux. And I use most of these daily. And so if you're like trying to remember what the heck is the K flag on the ls command, right? You type man ls, and it'll give you the manual and it'll show you all the flags. There's a lot of flags available for ls, so that's a bit daunting. But let's see. So F is display / immediately after each path that is a directory. So instead of showing you the name, like in this, ls-f will show it with a slash, which I like. If you don't have colors on, which I do, but if you didn't, it would be harder to distinguish which ones are directories and which ones are files if you don't have extensions, right? So now, like random test, that doesn't have an extension, but I believe that's a shelf script that I wrote. But if
I like to think F stands for fancy.
fancy, that's nice. I like that. Yeah, let's go with that. So you throw the fancy flag, and you get some fancy output. So let's see, what else? There was L. So this is that's the uppercase L. So, and something to note is everything is case sensitive. And so a lowercase L flag and an uppercase L flag are potentially different. And that could vary pending operating system and Linux distro and all that. But yeah, that's at least on a Mac, things are cap sensitive, so you can get different output if you accidentally throw the wrong capital or lowercase letter. So dash uppercase L is following symbolic links to the target. So if there's a link which is symbolic, meaning it's not a hard link between two files in your system, it'll follow the link from the file that you're currently in the directory, and it'll find out where that file is linked to in the other place, right? So a way that I use this every day is I will link scripts that I've written to commands in my alias, and then alias them in my shell. And so basically what that's doing is I can link something in, like, for example, /user/Bryan/local/bin. And I'll show you what I'm talking about. So in here are a bunch of scripts that I've written that are my own utilities, right? So ACP is short for add, commit, push. And so I can do ACP and it'll walk me through the process of doing an add and commit, and then I can like type a message and then it'll ask for a branch name, right? And I give it a branch name and it'll do the full process of adding, committing, and pushing to Git. And so what I've done here is in this folder, in this directory that's called, I've just created local and bin. And then if I go to like if I went to the origin, which is a Git repo that I cloned locally, and then what I did was I symbolically linked all of the scripts that are in that Git repo to my local drive, such that now if I echo my path and then try and use regular expression to grep and find a specific thing. So in my path, I've put user this exact where I am now, right? So now whenever I run a command like ACP, or if I try and figure out what it is, I can see, oh, it's been aliased to this path in this working directory here. And so basically what's happening here is my shell is interpreting the path, finding the access to this ACP and running the script there. And so that's like symbolic links are kind of like a huge value add. So anyway, sidebar, but let's see, the whole point here was to find the -k. So K says this has the same effect as setting environment variable block size to 1024, except that it also nullifies any H options. So whenever you're long listing was ls-k, or I guess it's probably ls-lk. Yeah. So these are the sizes in bytes, and it sounds like it's basically, let's see. $10.24. Interesting. Is 1024 the number of kilobytes or bytes in a kilobyte? So it should show the size of files in kilobytes.
I think I usually use, instead of K, I usually use H.
That's
for
H.
Human readable.
Yeah. It looks like it doesn't work unless you're long listed, which makes sense. So this is LL is ls-l. This is your long listing. This shows you D, which stands for directory, read, write, execute. And these first group of 3 correspond to the user. So that's me. Bryan is the user here. And then read -x. These 3 correspond to the group. In my case, I'm part of the staff group. And so what this means is Bryan, user, can read, write, and execute any of these files that have RWX in the first 3. The second group is read and execute. So if somebody else was on my machine, or if I were on a server and there's somebody who's part of the staff group, they can read from and execute files in, or execute a command on anything that's R-KX in the second group. And then the last group of 3 is other. So anybody outside the group. So just any person, any user on the entire system, in this case, could read and then execute a command on this, but can't do anything on like for example, the movies, the music, the pictures, etc. And then you've got, actually don't know what this second one is off the top of my head, but maybe we can look that up. This is your username, this is your group, this should be the size of the file, and then this is the date, the last time it was edited. And so if I did like LL-H, like Stephen was saying, which I use often as well, it actually then shows it in a human readable format. So you can see the bytes. So 128 bytes, 46 bytes, 1 kilobyte. Something to note about -H, if I'm not mistaken, it rounds up, I think. So it's not giving you like to the byte size, but it's close enough if you're trying to just read it really quickly. Yeah, I guess so. Let's do LL. Yeah, there's no difference here between LL and LL-K. Oh, that's because, yeah, LS-LK. Yeah, that's got to be it, right? No, there's no difference there either. I don't know. That's interesting. I don't know why that is. At any rate, so we've covered F, we've covered L, A. Include directory entries whose names begin with a dot, right? So that's what I would call anonymous files. S, let's see, what does S do? Display the number of blocks used in the file system by each file. Block sizes and directory totals are handled as described in the long format subscription below. So another way to kind of display the output of the size of things. So cat. All right. So let's see. It's man cat. Cat concatenate and print files. So also a very useful command that I use a lot. So for example, if I get a listing, I see urandom test. That's a file. Something else I guess I skipped over was these are directories. Usually there's something here, but maybe because it's a file and it's not it's not sure what it is. It's just showing it as a dash. Sometimes there'll be a different designation there, like F, or if it's a socket, it'll be S, or if it's a link, it'll be an L. So yeah, just something to note. So if I cat this urandom test, I can see, okay, all that's in there is testing with a percent sign. I wanted to look at that and use them and see, okay, it's just the word testing. So not much, nothing really cool there. Let's see, cat test. Okay, yeah, so this is just a random sysr Python file I was playing with. So you can just, I've aliased, for example, cat Z, and that cat's my entire ZSHRC. So let's say, for example, like I have so much stuff in here, like I forget sometimes what's in there, or if I'm like, oh, is this present, right? So like, oh, is rand pw present in my ZSHRC? Well, I've aliased it to cat Z, so this is going to run cat /.ZSHRC, and then I can grep rand pw, and I can see there it is. But I've also done something where I've aliased grep to grep Z, and then I can just type that. And so it's actually grepping whatever I tell it to after it's catting the ZSHRC and then grepping whatever's after it, which that was interesting. Why did that? Oh, yeah. So rand pw is also a command that I have, and it basically generates a random 4 or 5 or I guess I killed that feature. So by giving it rand pw, is actually trying to run the alias that I have for rand pw, which is alias to this. So if I run rand pw, it's going to alias and find Python 3, and it's going to run this Python file. And so by running grep z rand pw, it actually tried to execute this. The shell interpreted this as a command, and that's why it actually popped out this. I don't know why it highlighted Python 3. That's interesting. I guess it grabbed the first line from this file. So if I cat this file, yeah, so the first line of this file is this. And so by running this command, so grep z and -v. So this is catting my ZSHRC and then grepping whatever is at next. But because I gave it a command, rand pw, the grep read in the first line of this random password.py file. And so it returned back the match as Python 3, which is interesting and weird.
So you had to put it in quotes to make
So I had to put it in single quotes, which I wonder if I put it in. So there's a big difference between single and double quotes in the shell interpreter. So double quotes works okay. Single quotes is kind of like your catch-all. If you wanted to ensure that you don't accidentally like run a command, or like you want to truncate basically everything within it, that would be a variable that would be read in by the shell interpreter. Single quotes is the way to go. Double quotes, you can still do things like and so like shell with the single quotes around it echoes out what shell is as a variable in the so you're referencing a variable with a $sign, and then shell is a environment variable that's been set to the bin ZSHRC ZSH. So I wonder if so if you throw a double quote or a single quote around it, it truncates the variable. So it just echoes whatever's in there. Instead of here where it's actually echoing that, or same thing for here, same effect, but single quote will prevent it from reading the variable. If you just type env, you can see like all of your environment variables that are accessible globally by your shell. So shell, home, log name, user, all that. All right. So I'm not going to go into more or page. They're basically the same thing as cat, just with various slight nuances. But if you're curious, feel free to dig in. Head is a good one. Head is kind of what it sounds like. It does the same thing as cat, but you can give it a number as a flag, and then it'll only print out that many that many lines from the file you give it. And so if test.py had a lot more lines, let's see if I give it 11, we'll print another one. How many lines? Yeah. So that file looks like it's 11 lines long. Yeah. And so by printing 1, you just get the first line. And then tail is the same thing, but in the opposite direction. So tail will print the last line, and then everything up into the number you give it. So also kind of useful if you're looking for something at the front or the back. These commands are useful in themselves, but they're also useful with other commands, and that kind of goes back to the philosophy of the Unix shell and the pipe capability. So if you wanted to pipe this and like find something and colorize it, you could grep color and then say n flag. And so it's going to look for the last 10 commands in this file, pass the output of that to this grep command, and then by colorizing it, I see it in nice clean red, what I'm looking for, and I gave it a pattern. Right? Make dir, rmdir, cd, so you can mkdir, tests, so there's my new test directory, cd into tester. See, there's nothing in there. And then I can go back and say, oh, I did that accidentally. Let me delete tester. And so now if I try to cd into tester, this is file correct. So something to note about rmdir is if I make that dir directory again, cd into it, and then I use like touch, which is, let's see, and touch. Change file access and modify times. Interesting. I've always used it as a way to create a file, but I'd also use it in my daily development as a way to restart my server. So my server is constantly looking at this one file, and every time it gets, quote, touched or changed, it then restarts the server. So I make changes to the server side. I run a command. That command touches that special file, and by touching it, the server sees it as now having been changed. So that's probably what it means by the modification of times. It's modifying the timestamp of when it was last edited, and without actually doing anything to the file. And so as a result, now the server sees, oh, this file has been updated, when really there's nothing in the file. It's just a pointer. Now the server updates, and now I can see the changes that I made to the back end of my application.
Comment from Grant watching the stream, the tail is great for looking at log files, so you can use tail to get the last number of entries in a log file.
Absolutely. I use it a lot for Bitcoin, actually. So I still have Bitcoin on here. So I don't have a log there, and my SSD is not connected, so that's okay. But if you do something like tail-f, right? So let's look at tail and look for the F. So the F option causes tail to not stop when end of file is reached, but rather to wait for additional data to be appended. So let's say you're like running Bitcoin, right? And you need to see like what's going on because you didn't run it you ran it as a paper, the background process. So you're trying to interact with it with the CLI, Bitcoin CLI, but you're getting this weird error that's like, are you sure the daemon's running? You're like, yeah, I'm sure, I just ran it. Well, if you wanted to figure out what's going on, you can take -f, and then you can pass it the path to your .bitcoin folder where all of your Bitcoin information would live typically, and then your debug.log, because on start, the Bitcoin daemon produces this debug.log file, and that's where, if you run it as a daemon, that's where all the output gets saved. And so often when I'm running Bitcoin from my laptop here, I will run a tail on this file, and I will start the daemon and immediately start tailing this file, and I can see Bitcoin starting in real time. I can see it just printing to the screen as it's printing stuff to the debug log. So not as impactful without a continuous output. Maybe in a minute I'll connect my SSD and start up Bitcoin. So something to note here about tester, if you create a directory, and then let's say, so now I have a test file, and if I edit it, if I cat that, cool. So there's something in there now. And so if I go back and try and do rmdir, it's not going to let me because the directory is now not empty. So that's something to note. I don't know if rmdir has an override flag. Let's see.
I usually do. I usually use rm and then I do the capital D flag.
For directory?
Or yeah, I'm pretty sure. Or no, actually, I think using capital R for recursive, will actually do the same thing.
Mm-hmm.
Yeah,
that's right. I don't know that. I don't use rmdir often, like you're saying. So if I wanted to like rm, like remove all of that, the whole directory, I would do the same thing that you just said, Stephen. I would do rm-r, and then if you do that, it should. This is file directory. Cool. So it not only deleted the tester, but it deleted the file in it because -r is recursive. It's just going to go through the directory and delete everything that's in there. Sometimes when you have a lot of files in a directory, or you'll have directories inside of directories with files inside of those, using this -r flag will then prompt you every time it wants to like delete a folder inside of a folder or a file inside of a folder inside of a folder. And so if you're sure you want to delete it and you're sure what you're going to delete is like deletable and you're not going to like regret it, you can throw a F in there to force it not to prompt you every time it's going to delete something. So I actually use this a lot when I'm, sure I'm going to kill something. I think I aliased it actually to destroy.
don't they call that rem wrapping?
Is that what it is?
Because you're doing rm
Oh
-rs, so it's called a rem wrap.
Yeah, that's a good call.
So definitely don't do rm rf/.
Yeah, definitely don't. That's the joke, right? Is definitely don't do rm/rf/, because you'll delete your entire root. There was like, I remember when I started buying a bunch of like coding t-shirts, there was one that was like don't drink in code, and it had like sudo rm-rf/ on it. I was like, I wonder what this is. Let's see. So this is again like cat, super useful. All right, cool. Read. You're about to destroy. Are you sure? It's funny. So like, destroy. You random test. It didn't. It didn't actually work right. That's funny.
I didn't prompt you.
No, it didn't prompt me. It just went straight through it. That's great. It's a good thing.
Tell me again what happens when you just do RM without the RF.
So yeah, just R. So that's good. Let's do
I've definitely been able to delete files
RM dash.
just doing that.
Yeah. So there you go. If it's just a single file, like it should let you do it. Let me make a dir.
I mean, I know. Is it the same as like on Windows? There's a recycle bin, and it doesn't really permanently. Because I know on Windows you can do like shift delete something, and it deletes it without putting it in the recycle bin.
Yeah.
Which I use that pretty often. I don't know if that's like the difference.
Yeah, I think I remember talking about this last time, and my initial understanding of RM was that it's destroying the reference in memory, but it's not overwriting the bytes at that reference, right? And so
It technically you could probably recover it somehow.
You probably could. I actually don't know how, but
Yeah.
I'm pretty sure, Steven, last time you were talking about there's like a safe destroy, and it's like part of the government specification on how to like safely destroy and overwrite the bytes.
DoD wiping.
Yeah, exactly. And so like, if you just like delete it, it's just gonna go to the recycle bin. If you delete it from the recycle bin, it's gonna do the same thing as the RM command.
Okay.
Yeah.
Also, Steven, that's the Bryan toilet paper left on DoD wiping.
All right, cool. So CD we covered, right? CD, if you just type CD, it'll take you home. CD/, it'll take you to root. CD again, it'll take you home. So that's just moving around. RN, move. So move's a handy command. If you wanted to change names of a file, right? So let's change DWN skjs to just dwn.txt. So now you can see DWN is that it was -SDK-SJS.txt, and now it's DWN.txt. And so giving move a current file name that exists in the working directory and then a secondary name will rename that file whatever. It'll rename the first file as whatever you give it the second. So if I do something like, which I've done before, I've or messed up and like accidentally done something like that, I'm like, oh crap, like I didn't mean to do that. It'll rename it, but you can just rename it back. You're all good. So it's not like a permanent thing. CP, so dwn.txt, I do give it a file CP and then give it should throw an error. Yeah, so CP is going to copy the first thing to the second thing. First thing being something that's existing within the current working directory. But in this case, I give it the same thing twice. So it can't, you can't have the same reference identical. So if I did 2, I now have a copy of whatever's there. Super useful command for me, especially because I do a lot of like messing with remote dev environment, and sometimes I'm nervous about running a command, and it's going to overwrite a file. So I'll do a CP and do like dwn.txt, and then do dwn.txt.back, which usually stands for like a backup. And now the backup of that, and then if I do something like crazy with that dwn.txt, I now have something to reference later. When I can make
Really
edits.
important config files and that
Oh,
type of thing.
absolutely. Yeah, like if you're on your this is my personal server for my website. It's like when I was learning how to do Nginx stuff to then like route my domains. Like these are all the conf files that exist to route these different domains to different content on my server. And so like when I was first learning how to do this stuff, I was just editing it in line and it took me a while to realize all I had to do was do a copy and copy it to a backup file because I was editing things and then being like, crap, what was it before that? I don't remember. And so you can see here I have a back folder where I've backed up every single one of these count files. So that way I can, cover my ass, so to speak.
I know I've done that for the config file for my nodes.
Yeah.
Tweaking things.
Exactly. All right, cool. So some of these are useful. I'll breeze through them so we can move on because I want to get to stuff that's a little more fun. Like file, I actually don't know what that does. So let's see. It tells you what type of file it is. That's cool. Directory. Cool. Yeah, that's neat. Let's see. File.zsh. ASCII text with very long lines. Cool. Thanks, Shell. Word count, WC. Let's see. So it's an empty file, so it's going to show you zeros. But if let's see, PS aux grep or pass it to word count. Yeah, okay, cool. So like PS aux is showing you all the background processes with user, PID, all these different fields. Because I pass it into a word count, and it's counting, I think, let's see, man, what are these numbers? Word, line, character, and byte. So it looks like it only showed me 3 things, which is odd. Lines, words, and bytes contained in each file or standard input. Yeah, so I gave it a standard input because I piped the output of PSOX into it. So it showed me the lines, the words, and the bytes. So that output has 558 lines, 6,800 words, and 108,000 bytes. Groups, pretty standard. Just shows you the groups that are on your computer. So staff, Damon, everyone, local. These are just these speak to this in the long listing for a file. You can see the permissions. So permission, read, write, execute, user, group, other. So you can see groups here. In this case, if somebody's part of the staff group, they'll be able to do this stuff. This is a Mac, so there's a lot of like weird built-in groups that I don't know what they do.
I can't remember. Did you go over groups last time?
I actually don't know. I don't think so.
Maybe it's time to touch on how those fit into the kind of Unix philosophy. Stuff.
Yeah, that's a good call. So so whenever a user's created, they belong to like a default group. So let me go into my Linux machine. So it's much simpler on a Linux just because Mac has all this proprietary stuff. But in this case, you can see I have a Bryan group, a sudo group, and an LXD group, which I actually don't know what that is. I don't know why that's there. I got hacked.
Dun, dun, dun.
It's for containers, usually snaps.
That would make sense. LL/home. Yeah, there's only one. That's interesting. I guess that's a group, not a user. Okay, so anyway, so if I look at who am I? Yeah, so we can see my username is Bryan. Can I give groups a username? Yeah, so it's showing me what groups this user belongs to. And so what is this? Why is this valuable? Well, if you wanted somebody to get onto your server, but you didn't want them, for example, accessing like in the root, you can go in a Ubuntu, you can go to home, and this is where all your users live usually. So if I had more than Bryan, you'd see Bryan, Steven, Grattan, Chad, Jordan, and we'd all have different directories where all our files live. So when you do a CD, that's where it takes you to your home/username. And then these are all Bryan's files, right? So in this case, like I can read and write most of this stuff, read, write, execute a lot of it. And even like some of the stuff, like if, for example, Grattan had a user on here, he could actually read, write, and execute things like rust up or SSH that are in my Bryan folder. And if I didn't want him to, I could create a new group that says read only. And then I can add Grattan to the read only. And then he could then I give the permissions of only R for everything that's in /home/Bryan. And now Grattan can only read things that are in that directory, home Bryan, because he's part of that group, and that group only has permissions to read things that are in that directory. And so it's a way to permission out what users can do in a much simpler and easier way, because you can add them to a group that has predefined stuff. So you can imagine like you could have a pseudo group, which is obviously super users, so they can do anything. You could have a read-only group. You could have a read-write group. You could have a read-write-execute group and give them different permissions on different folders to do different things. As an example, when I was at GSU, we had a school snowball server, and we all had like limited permissions on what we could edit where. So like we couldn't edit our teacher's drive, but we could edit our own drives. And I can actually edit other students' drives, so I'd like go in and mess with other people's shit. Just a message.
I think there's this phrase, about don't manage users, manage groups.
Nice.
Something like that.
That's good.
System administration. Yeah.
Mm-hmm.
But it's kind of interesting that we have tools like Discord and stuff, and you can create like different roles and stuff for people in your Discord server. But this is like very, very similar concept, but just very, very, sitting very close to the operating system.
Exactly. Okay. Absolute paths are pretty straightforward. If I pwd here, this is an absolute path. So if I cd/edc/nginx, I'm giving it an absolute path. That will take me there. But if I cd to tilde slash, that's a back to my home. But if I wanted to go, let's say, into HTML, so now I'm in home Bryan HTML. If I want to go back and then go from back, not just back a folder, which is .. but I want to go back and into another folder, I can give it .. slash and then the name of a folder there, and now I'm in that folder. And so this is relative pathing. It's a way to just understand if you know what's already a folder up or a folder down or whatever, you can go back and use the relative path. But I can do the same thing here as .. So if I was in, so if I'm in here and I wanted to go to that same local, I can give it this whole path. Same thing, equivalent.
Right, would it be correct to say that an absolute path always starts with a slash?
Yes, that's a good way to put it. Absolute paths start with slash in the beginning, and relatives start with a dot or a .. So change group. So again, manage groups, not users. So you can change groups of users to different. So if I wanted to give Grattan root permissions, pseudo permissions, I could change this group from read only to root. And then chmod is really useful. So like sometimes, for example, when you're installing Node.js on an Ubuntu or a Linux, what's going to happen is you're going to have to, or for a better example, if you're installing N, right? So N is a way to manage your packages, your Node packages. So if I want to shift between different versions of Node, I can type N and you can install it via the npm.js. So npm i-g n, it'll install this package that will let you manage. But the problem is on Ubuntu, the way you have to install it is with in global, and that gives it ownership by the root. And so whenever you, after that, try and do like nlts, let's say, because I rearranged it such that it works with my user, if you don't have full sudo permissions as that user, it will install it. But then when you go to look at the version, it won't have updated because the path where that stuff is being installed is in a sudo or a root, and you're just a user, you don't have the sudo permission, so you have to do like sudo nlts, and you have to do that over and over and over again. So every time you want to like something like that, you have to actually have the sudo permission and put in a password, and it's super annoying. And sometimes if it's not set up right, you try and do this and it'll fail. It'll say you don't have write access to the folder that N is trying to install this version in. And so a way around that is chown. So if you give chown a folder, so let's see. So this is owned by root. So if I want to own it by my user, I can give it chown Bryan and then a path. I'm gonna have to sudo. I think I just mistyped my password. Yep. All right. So yeah, so there you go. So now it's owned by Bryan by giving it like sudo. You can also do a user here. Because if you echo the user variable, it'll print out my name. And then chmod. So in this case, let's get out of this and all right, cool. So I have a little script here called clean groups. So if I try and run clean groups like this, it's going to say command not found because it doesn't know how to interpret this thing. But if I put an sh, it's going to run it because it now knows to run this shell script through the sh interpreter. But let's say, for example, I I wanted this to be executable without the sh. So I do chmod, and I could give it user plus execute, and then paste the name of that file and hit enter. And now you can see it shows it was read. It's read, write, and execute. And now I should be able to do, right, or this may still fail. Yeah, I think this is still going to fail. Yeah, so that fails because you have to actually give it the relevant path to it. So it knows, because the only way to get this nakedly to work, like so, would be to add the dot to your path, and then it would be reading and everything from the current working directory as executable. At any rate, the point here is I changed it from read and write to read, write, execute, so I don't have to use the sh in front of it. And so if I wanted to change it back, I could do user minus x, and now it's not read anymore. Another cool way to work with the permissions is octal. So permissions can be read in as either the semantic human readable way or octal. So 700 would be, 7 means read, write, execute for user. And if I did 770, it would be read, write, execute for user and group. And 777 would be this read, write, execute for user, group, and other. And so if I only wanted me to be able to do all three on it, I could do that. I believe it goes up in 1, 3, and 4. So read, write, execute. So 1 plus 3 is 1, 2, 4. So 1 corresponds to X read, this is write, and this is execute, and you add them up to get the octal number that corresponds to the permission. So if you just wanted to give read and write, you would give it a 300. Write and execute, so I messed up my numbers there. So 1 and 2, so that must be write, execute, and read. But anyway, I won't get into the details on that if you guys are curious. It'll log it down, but it's just a different way to change permissions. Yeah, 755 is a pretty common one. Make a file readable and executable by everyone and writable by the owner only. So whenever I'm provisioning Nginx comp files, and then I point it to a directory on my server so that whenever a request comes into nonni.io, it'll show the content for my website. The content and the folder that all that content lives in has a 755 permission, because I want everybody on the internet to go to my website and be able to read it and execute commands because you're interacting with the script. But I don't want them to be able to write. So I have that permission. All right. I think that's most of the stuff in this. I wanted to show this and point this out for everybody. This is in my repo. It's a really good reference. You can print it out, put it next to your desk or something. I used to do that. It has a lot of stuff on here. So if you finger, which is an interesting command, will show you all kinds of information about that specific user. So anyway, definitely would reference this. There's a lot of stuff, including like how to install file, different packages and grepping. And so let's move into the next thing. Another cheat sheet, basic bash cheat sheet, also in the repo. It's called bash cheat sheet markdown. All right,
It tells me I have to sudo apt install finger.
Oh, interesting. So it's not by default. It's not included in your system.
I guess not.
Yeah. So you have to install that, which happens like, for example, page. That's not a command that comes with Mac out of the box, but more is. And cat, more, and page are all basically the same thing. So if I wanted to install page, I could probably do brew install page, and I can install that specific package. So for you, apt install. Cool. All right, regular expression. So this was a bit of a doozy, but hang with me, and feel free to jump in and stop me at any point to ask questions, because there's a lot that goes into regular expression. So yeah.
I just want to chime in real quick and say that like this is like such a hugely dense topic, but it's like so powerful once you learn it.
Yes.
I mean, it's the kind of shit where like you just have like a whole page full of code, and there's some specific element or attribute that you need to change like 50 times in one file or 50 times across 50 files, and it's like regular expression is just like something that seems like simple, like 3 characters, just like is magical and just lets you just like completely find and replace thousands of strings all at once. So just want to highlight kind of the power of this. The complexity that Brian's about to show you is worth it.
Yeah, thank you. That's definitely good to know, because yeah, it is a bit of a dense topic that's hard to chew on. But I just want to start by showing you guys a really good tool that I still use to this day. It's called regexer. You can put in a pattern here and then put in whatever you want to match it to. So, like for example, if you wanted a URL matcher pattern, which I recently used, right? So grab a URL, paste it here, and then you can look in this little sidebar for a cheat sheet, and it'll tell you what different characters correspond to with respect to what they're trying to match, right? So in this case, a period in a regular expression matches any character except any line, right? And so like, see how it's individually highlighting each individual character, because it's not recognizing the whole word or the whole string. It's matching against every single one of these on their own, right? And so anyway, I just wanted to point that out. It's a good tool. We may come back to it in a bit. But let's get back to this. So yeah, pattern describing a certain amount of text. Let's see. Regular expression, or regex, is a pattern matching engine. So, and a match is a piece of text that pattern was found to correspond to. That's a really crappy way of describing it. It's a way to pass in a list of a pattern, and then give it some text to match against, and it'll find the match based on the pattern. And so the pattern can be, for example, and this is where grep comes in. So I can't remember what grep stands for. Does anyone remember?
Global regular expression.
Thank you. So, I mean, it's literally a tool built for regex, right? It's a file pattern match searcher. And so, for example, like I could do cat.z shrc, and then pass the output into a grep command, and then just, I could give it just a basic string, right? So it's looking for anything in the contents of this file that matches the word test, right? But let's say I just wanted to search for any time there's a digit. So in this case, the pattern would be the keyword that you're trying to invoke from regex is /D, which matches any digit. So if I give it /D, so you see how it highlights all the digits. And in this case, because the way this gets read in by the shell, it interprets literally D and /. So you have to wrap it in double quotes. I think if you wrapped it in single quotes, it would actually truncate. No, it still works. So that's something to note. So as long as you wrap it in a quote, it's going to then interpret. grep is going to read this in as a regular expression matching pattern instead of just a literal string. And so that's kind of like a basic, how that kind of goes.
So if you did grep period, it would literally just all be red.
Let's see. Yeah. So I don't know what it's doing. It's just, it's like returning everything multiple times and highlighting certain things, and it's like highlighting part of it and then not the last of it, but then the next line it's highlighting the last of it. It's probably something to do with the way the grep engine is like reading in the information, and
It's almost like a diff.
It's like straight through the center. It's like there's a max
Yeah, you're
count
right.
or something.
Yeah.
Maybe it's a grep thing.
Maybe it is a graph thing. Like the buffer is limited to.
Yeah. That's interesting.
Yeah, that is interesting. Never really tried that.
Never either.
So like for example, 9/5/2016. So let's do echo 9/5/2016. Type that into a grep command. Wish I could copy and paste. So this is good. Yeah, so this is good. All right, so it returned nothing, right? But according to this example, it should have returned at least part of the, it should have returned, so D is digit, curly brace tells the regex engine, I want to find one between 1 and 2, so of length 1 or 2. So a minimum of 1, right, so 9, and a maximum of 2, so 0, 9, right? Here, / so in regex, the backslash is a special character that needs to be escaped. And what that means is if you gave it a / it's going to read in the / as whatever the / is meant to be for a regular expression. So if I go to / actually it's not, it's just, it's unescaped / just may cause issues with copying and pasting. So it can't read in, it just literally can't read this in on its own. You need to escape it to tell that you want to literally find a /. And so in this case, I'm telling it \d, look for a length of 1 to 2 with curly brace around 1 to 2 to tell it that. And then the slashes are the beginning and the ending of the regular expression. So everything in between these is considered regex. Yeah, so it didn't like, so it didn't like that because it's not wrapped in a string. But it's still not matching what it's supposed to. So I'm going to go out on a limb here and just go from memory and say that grep on its own has a limited set. So there was like,
hey, are those parentheses? It's hard to see on the monitor. Or are those braces?
those are curlies.
Okay, they're looking like parentheses. I was going to say the
Yeah.
parentheses. That would be the problem.
Yeah, that's fair.
Okay,
How's that?
yeah, that's much more legible now.
Yeah. All right. Yeah, I was right. All right. So grep, nothing, right? Egrep gave me the date, right? So let's see if I do. Interesting that it didn't find. Oh, it's yeah. Okay. All right. Cool. So in this instance, / I actually can't remember what the deal is with the escaping the / because here it's actually reading in both the /. Sorry, what happened there, right? So grep has a limited capability. So there's like, just like in code, you have like version 1 that has like a limited set of features, and then version 2 has an extended set of features, and so on that include backwards compatible features from all the other versions. So egrep stands for extended grep. And so extended grep gives you the ability to do more pattern recognition with more complex characters. And in this case, these curly braces are considered an extension of regex. They're an extended feature.
Huh.
Yeah. So regular grep won't actually read them in, and it'll look for literal curly braces.
So it sounds like the difference between V and them.
Yeah, exactly.
One question about, I don't know if you're sure of this or not, but with regex, was that the idea for regex? Was that originally implemented with grep, or like is there other like pattern matching? I guess I'm trying to figure out if, because you said that grep is extended grep. So does that mean that like the regular expression, like stack or whatever, changed? Or
I think there's different implementations of it. Like I know the most widely used one is the Perl regex. I think it's Perl. And so like that's the one that typically JavaScript follows, but not every language implements it the same.
I see.
Yeah, and that's a good explanation. It says basic regular expression, ERE extended regular expression used by Unix utilities such as grep, egrep, awkset, vi. That's a confusing sentence, but it's basically saying like grep uses this, egrep uses is used by this, etc. Awk and sed and vi are also engines that I'm going to try and get to because they're also I use awk and sed every day. Super useful.
So it looks like, just if I'm getting this right, those languages that it lists first, those use basic regular expression and syntax, and then those other tools use extended regular expression.
Yeah, I think that's correct. Yeah, and this is kind of what kind of speaks to that like grep egrep difference is like all these languages have slightly different variations of how the engine works. And so you kind of got to look at the docs of each of these languages to figure out like Perl won't match on certain things, or to get Perl to match in a certain way that JavaScript would match, you have to like escape the character or do something fancy or different, whatever. So it's a little bit of a headache, but once you kind of master regular expression, it's extremely powerful. Special characters, literal characters are treated as words. Yeah. So yeah, so in this whole like thing, right? So let's go back here and type out the whole. Type that in right. 1,2 escape D 1,2 escape D 1,2 4. There you go. I wonder if that's meant for this. No, I don't know what the in different contexts. Again, it's confusing and annoying. But you see how like in this one it shows you. Indicates the start of a regular expression. So like, for example, in JavaScript, if you were to write a regular expression, you would start it with these these slashes. And then once you complete the regular expression, if you have a syntax highlighter in your IDE, it'll highlight that whole regular expression in red. And so you know it's a regular expression. And so JavaScript reads in a regex expression by seeing the slash in the front and back. And then you can throw flags in there like G. So G is global. Whereas, like, if you don't have G, it'll find the first match and then die. It'll stop. So if you have multiple matches in one string, right? So if you like echo, so I guess grep has a global, probably has global flag built in. Let's see if I put it in here and just do A and then, yeah. So you see how global is disabled, so therefore it's just matching the first instance. But if you throw, and this is also the case in JavaScript. And so like if you did it like a, so it only replace the first A. But if you do replace all, it'll replace all of them. So that's the difference is, this is no global flag, this is global flag. And you can also like, and that's defining, this is, so if I like R equals /A/G. So now R is set to this regular expression, I do R dot match. Wait, R dot test, yeah. And it'll say true because the regular expression is looking for an A, and I gave it an A. So anyway. So yeah, so that's also something to note. Like I gave it a full regex here, and it matched against the whole thing. But like, what happens if I deleted this off Yeah, so it's colorizing what it's matching, but it's giving you the whole line back. So if I don't put the color in, it would just give you a line. And so that would be a little confusing because you're like, oh, well, I thought I was just trying to match on like the 9/5. So color is helpful because it'll show you what it's actually matching against. But because regex is going to give you back the entire line that matches, it's going to show you everything in the, despite the fact that you weren't looking for this, it's still going to give it to you. So something to keep in mind if you're like, for example, going through a huge file and looking for stuff. All right, meta characters. Yeah, so this is what I was talking about with special meaning, right? So each of these does a different thing for regex, and these can be found again in this little cheat sheet in this regexer thingamabob. Where is it? There you go, cheat sheet. So, so for example, if I wanted to match, oops, let's see, a bunch of numbers and letters, right? Well, I just want to match the numbers. I can give it these curly brackets and give it a range. So you 0 through 9. So now it's going to match every single individual number that's in that string globally. But what if I wanted it to just be like length 1, right? That's still going to match. But what if I wanted to do length 2? So now it's going to match 54, 66. So it's going to go through left to right and find, oh, 2 numbers match, 2 numbers match. So if I give it like 1, 2, it'll match each of these individually as well as like pairs, right? And so it's like, that's almost like overkill. That's like a blunt force, way of doing it. Or if you did like 3, right? There's only 1 or 4, 5, but then eventually, there's no numbers with the string. So let's say I don't want to match the letters, but numbers, I want to match the letters. Same thing. A through Z will match each of the letters, but let's say I want to only match caps. Same thing, but there's no caps in here, so let's throw some caps in there. But what if I want all capital and lowercase? Well, luckily, regex has something for you. And then what if I want letters and numbers? So you can do this and specify like you want, any letter or number that is length 1.
We'll probably want half of the letters.
Would you all have any letters?
Only half of the letters.
Half the letters.
Yeah, can I do like A through, M or whatever?
Good question. Yes, you can.
Nice.
Yeah. I've never really thought about that. Yeah. What if I just did A? Yeah. Or what I just do A? Yeah.
Sometimes I only want half of the letters. I don't know.
So yeah, I mean that's a good point. It's like this stuff is like once you kind of get the pattern of how these expressions go, you can start playing with it. You'd be like, oh, what if I just want A through D? Oh, well, it'll do that. It's flexible. And yeah, that's something I was wondering if that would do that. You can't do that though. So it's either all caps or all lowercase, or A through D.
Well, I can imagine it. Like, imagine you were trying to write a script that would like locate every single hexadecimal string within like a body of text or whatever, and you want to be able to separate it out.
Oh, yeah.
And so you want to be able to detect it as separate from other strings, like separate the code samples out from the the human readable text or whatever. So you could write a regex that's like 0 through 9, and then A through F, and then with space or a period around either side of it, and you'd effectively select every hex string in the body.
Yep. Absolutely. I always forget this command.
Are you trying to do like a SHA-256 string?
Yeah. Bryan, that's what I was looking for. Cool. So now this is a hex string. And so you can A through F, right? Lowercase and uppercase. I'm sure there's a way to like produce it with uppercases too. But yeah. just an example of what Steve was saying. Where are we at? Yeah, so the brackets are your friend. Here's some examples. So all strings with any character preceding ND. So dot is anything, and then ND. So in this case, be OND, AND, AND, case insensitive, which is another flag, by the way, that I think can be used in all regex, including the shell. So you can tell it, I don't care if it's uppercase or lowercase. A period, which would be, a literal period, right? So in this case, it would just match the period. So yeah, these are, so $ signifies end of line. I think it's usually implied. You actually don't always need it. But if you wanted to like be very explicit, like for example here, a and then any character and then end of line. So this would match a comma, and then because that's the end of the line, it'll match a comma, right? So it's looking for an end of line character at the end.
It's very useful when you're editing, trying to do bulk replace in like large code files and stuff. So if it's like like a JSON object, you're trying to like write a script to format it or select certain attributes within it. Sometimes very powerful. You can select like a JSON, look in an array for a specific JSON object with these specific parameters on different lines and selectively replace the values of those parameters.
Exactly. You can be very fine-tuned and like just find exactly what you want by using the right combination of things. So like in this case, right? But then if I remove this, it gives me back all those things. And then you can do something cool, right? So you can do this little set command. Now let's say every A that I match against, let's replace it with a capital B. Do it globally. Right. So set is something I would like to try and get to in a minute, but basically it's a stream editor. So it'll in text that you give it, it'll do various things with it, right? So in this case, S is the flag for search and replace. And the first character between the slashes is what you're searching for. The second character is what you're replacing with. And then this is obviously the flag. So I wonder if I works there as well. Yeah. Yeah. If I throw that I out, yeah, it did not replace the A that we have away there. So anyway. Question mark, 0 or 1 occurrence. So A question mark. So let's see. Yeah, so that's an extended grep functionality, question mark. Star is any number, I think. 0 or more, right? So, yeah. And then plus is 1 or more. So, similar functionality, but this is not as a useful example, obviously, but it can be very useful in different contexts. So parentheses are a group. So if I want to find a group of A's, that doesn't exist, right? But if I lowercase this, it'll give me back that. And then let's go. So now I've said a group of 2 A's, 1 or more occurrence, right? So it's going to find each group of A's. Pipe. So pipe is or. So AA or BB, but there isn't BB. So if I do BB, now it'll find BB. But if I get rid of that, obviously it's not going to find anything. It's looking for AA, BB. So useful. You can do something like this as well. And now it's going to find a group of A's or a group of B's and one or more of these. And you can get really fancy with that logic. So a group of A, B, at least one, max 2 length, followed by a C. And you can see A, B, so A, B, A, B, C. That comes back. Character classes, yeah, like white space. So if you want to match white space, you throw that in there, all that. Rules, so that's the end. So let's move into this. Yeah, awk and set. So awk, yeah, this is grep. We went through that a little bit. More. Give me more. Set, there we go. Stream editor. So select the match lines. Action, things to do is set. So you can delete lines, you can print lines, you can substitute things, you can insert lines. So as an example, let's there's two ways to kind of use it. You can use it from the command line like I did a minute ago. What is the 1, 100? I believe that's like referencing line numbers. But yeah, line. So this is telling the stream editor look from lines 1 to 100, and anytime you say a capital A, replace it with a lowercase a, and do it on this test.txt file. So
So it's essentially find replace.
yeah, essentially for this specific s slash.
Okay, it does more.
It does. So if you give it a D as the action, it'll delete lines that match a pattern or a condition. And so let's see if I can find an example. So sed /A is the pattern, / and then D, and this should delete all lines containing A. Right? So let's copy the test.txt to t.txt, and then let's do sed /A /D test.txt, and then just put it to the output. So, I guess it doesn't. Yeah, so there's nothing in there, right? Because this is one line. So let's, I'm going to use nano because I'm not sure. Okay, so there was only 2 lines in that file that didn't have an A in it. And so it deleted every other line except those 2. So that's kind of an example of that. Printing lines containing A. Substitute?
No.
Right. So again, telling sed to print lines that match this pattern, and then telling it the file to do it on. Try without -n, what will be printed, and suppress the automatic printing with pattern space. Let's see. Oh, interesting. So it suppressed lines that so sed is printing out everything, including lines before and after matches. Right, so I want just A's, but it's printing out this line. It's printing out this line. So if you throw an end flag, it'll suppress that output, which to me seems like should be a built-in feature. But I guess it's just like, hey, match, print, and then it keeps printing, hey, match, print, which is funny. So let's see if I give it a length here. So I guess this is another way of just printing like lines 5 through 6. Yeah. So that's cool. Same thing. Oh, I see. It's saying 200 to 300. Yeah. So I guess it would just start printing, and then if you don't suppress it, it'll print more than just what you're asking. So substituting text, same thing here that I mentioned earlier. Like S is the flag for the command to tell it search and replace, and then you give it, something to search for and something to replace. So this indents each line within the file by 2 spaces. So let's try that. So there you go. So that's kind of neat. I didn't realize this was looking for, I guess, the start of new lines. Yeah. Yeah. So this is the start of a new line, right? And this is match against the end of a new line. As we mentioned earlier, the dollar sign was match the end of the line. So the caret is to match the start of the line. Yeah, so another way to do this is you could write out sed commands into what would be called a sed file. And so so in the practice folder, there should be a sed folder. And so this is an example of like a sed script. And so in this case, I think this is from this slide, yeah. So /I looks like add 2 lines at the beginning of the file, right? So 1I / should add lines at the beginning of the file. And so you could, if you wanted to, stick this into a file and then you could pass this sed, insert sed into the sed command, giving it a -F. Tell it to read the commands that I've outlined in this sed script and then do them on this dummy file. So let's try that. So it added what was in there, right? Which we told it, insert these following lines. So you're telling it insert at the beginning and then insert this and this. And so by running that, you can see that this is new text, more new text. So it's useful if you're trying to like edit files on like a remote server and adding things and moving things and things like stuff like that. Yeah, so this is more of like the same fundamentals, right? Is like you can match against something using regular expression and then tell it to delete that one thing. You get very fine-tuned and only delete certain things or a lot of things. So awk, I like awk a lot. So let me. So this is probably one of the first awk usages I found in my daily life. So I wanted to see like my computer's bogging down. I don't really want to open my activity monitor to see like what's eating what. I just want to see it from my terminal because I just want to use my terminal all the time. So I created this little script that basically clears the screen and then it runs a PS aux, which gives me all the background processes on my computer. And then it uses awk and a pattern to basically print the number of rows that are less than or equal to this number, right? So in this case, that's the top 10, which that's a really gross output. If this were smaller, which nobody's gonna be able to read this, but so if I went into my activity monitor and look, it's sorted by like CPU usage. Brave browser.app, Brave browser helper. So you can see it here. I'm basically using awk to easily just see the top 10 things that are bogging down my CPU by catting these, basically piping these commands together and then I put them into a script on my computer, and then in my Z shell RC, I alias the word usage to point to that script. So now every time I run usage, it clears the screen and shows me what's eating up my CPU. And so awk is like probably one of my favorites. It's got a lot of useful features. Like for example, you can do anything in between the curly braces is like a command, right? So for example, if I just do ps awk, it's going to give me a big output of columns, right? Denoted or delimited by spaces. So let's say I just want to see one of these columns, right? I just want to see the user that's using things on my computer. Let me zoom back in. So if I type ps awk and pipe that into an awk command, and then I tell it print $1, enter. So you can see that it output just the first column. And if I wanted to slim this down a little bit, so you see the user, Bryan, Windows Server, core audio, Bryan. So this $1 is a variable that awk reads in, and then based on the input, it'll delimit what the input is by some default, right? So in this case, it's delimiting just by the spaces. That's so bad. So it's delimiting by the spaces in between each of these. That's not it. Yeah, okay. So user PID, these are like the column headers. You can think of this almost like a CSV file, except instead of commas, there's spaces. And so by not giving awk anything to match on, by default, it's just going to give me, it's going to find those columns based on the space in between them. And then it's going to give me back the first one. But what if I wanted to see like more information? So I can give it 2, and you see how it's kind of gross, right? So you can do something like this.
So just by default, any like area of white space it sees as being a column.
Yeah, but let's say like you wanted to be explicit. So you can explicitly tell it, find the columns in between with this separator, right? So if I did something like, so you see now all the white space has been replaced with these little dashes.
Yeah.
And so then if I pipe that into an awk command and give it a -f flag, and then give it this character and tell it to with 1, it's going to do the same thing, but instead it was matching against the dash, right? So it's basically if you have output that has a pattern in it, that can be split, and the output also has like a way to split it from left to right horizontally. You can then give it that, and it'll do the work for you.
Yes.
Yeah, I really like awk. It's a lot of fun to play with. I use it a lot for things like, for example, what if I just wanted to see, like, what if I wanted to sum up all the bytes in my home directory to get a full size of bytes of everything in here, right? Well, this output of long listing gives me that kind of column structure. So this is awk is a 1 indexed engine. So this first one is not 0, it's 1. So 1, 2, 3, 4, 5, 6. So let's pipe the output of LL into a print command and give it $6. All right, cool. Now I've got a string. I've got a list of all the bytes in my folder. And then All right, so what I did there was I defined a variable called bytes, set it equal to, and then I gave it this $sign and a parenthesis, which is a special character for I'm now going to run a command or give you another variable or something unique or special inside of these parentheses. And when this command runs, all of the output then gets interpreted as input to the variable bytes. So now I have bytes as a variable. So I can do 4 bytes in bytes. So I did a little loop there that basically just echoed each thing in that list, right? Well, let's look up. It's probably in one of my sheets, actually, now that I think about it. It kind of leads us into shell scripting a little bit.
Yeah, so did you want to try and cover some more material? Did you want to see if there's any more questions or?
Yeah, sorry, I was just trying to find the way to add in shell. But yeah, if there's questions, I can definitely do questions. I know we're right about it time, so. Let's see.
Well, I think in the chat here, I was curious to know if everyone here is feeling any I don't know, common command line problems you have, or anything that you're curious about learning more about now that after what we've been looking at today.
It's pretty impressive, some of the commands you were able to write off the top of your head.
For sure. I've been doing it a while. So you should be able to do.
So what you're doing now is shell scripting.
Yeah, basically, but just from the command line, like in the shell itself, right?
So it's like writing a program that doesn't actually live on a file.
Correct. Correct.
Brad, I have a question.
Yeah.
So when you're writing a multi-line command in the terminal,
Yeah.
a couple of questions. What's the best way to get to the next line? And then when you're finished writing everything that you want and you want it to execute, what do you press?
The multi-line command. So like for this for loop.
Yeah.
So by default, it should actually like see, okay, a 4, right? And so you hit enter and you can see how now it's kind of like opened up a script space for me.
Mhm.
And so then I can just type the rest, right? And so like echo byte and then done. So you just have to know like do done. You have to know some of the syntax off the top of your head, and then it'll run. But yeah, if you like,
So I noticed I'm using a different terminal, but it's not the Mac one. And
it doesn't.
when I do it, it doesn't have the 4. It just goes to a new line. It has like a caret, like a greater than sign prompt. Is it doing the same thing, you think?
Let's see.
Yeah, like that.
Yeah. So I mean, this is an Ubuntu machine, so it did the same thing. But here's the other way to do it. So if you're looking for like for specifically a for in loop, where you have like an iterator instead of like you're doing a for 0, I++, whatever, you can tell the shell with semicolons that this is a break, right? And so four byte in $ bytes, semicolon, do echo $byte, semicolon, done.
Got it.
Yeah. But I think the other way you could do that is
That's what I was curious about.
yeah. I know there's a way to do a multi-line like that, but yeah, I don't often do that. I usually just let the shell handle it for me.
I did get a for loop to work just by doing 4x in and then a range like 1 through 5.
Yeah.
And I hit enter and it has the little prompt. I did echo $X and hit enter and it prints out the loop.
Nice. Yeah, I'm trying to. I usually have I know I've had scripts that I really want to make this work. Let's try this. Let's something to, we'll probably have to do a third one of these one day where we really dig into shell scripting. But so shell scripting is probably one of the more powerful things I ever learned with the Unix, like the terminal. And it's just basically like everything you learned in this session and last session, you can use in a shell script and just automate everything, right? Like you can literally automate your whole life on a computer using shell scripting and aliasing. I mean, that's more or less like what I've done here is if I go to my local, I call it local bin. It's just in my like users/Bryan folder. And then I made a local folder and then bin. And you can see like, these are commands like stuff I created when I was back in school and just have continued to use. But like, oh, there you go. S++ surrounded. But yeah, if you look at this, it's like enter the folder name, starting number, ending number, while true. If $F, which I'm not sure what that's doing, is blank. Oh, right, because F, it's reading in F as the folder name. So if there is no folder name, then throw an error. If S is less than 0, throw an error. If N is less than S, then throw an error. Else, create files, inputs is false, kill this loop. While S, which is the starting number, is less than or equal to N, which is your iterator, your index. File equals $F, so that was your folder name. $S, which is your starting number. .text, and then create it, and then echo it, and then increment. So let's do it. There you go. So it's actually not a folder creator; it's a text file creator. But again, you could adapt this to be like mkdir, right? And then you could delete that, and it would create Unix testing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But anyway, so let me see if there's one here that does like a. Let's go back. Go.
Is shell sensitive to spacing?
Yes, very. All right, cool. So let's go to this and do. Oh, I saved it in a weird spot. You see that?
It went out.
Yeah. Let's see, copy path. Copy path. Move that to here. Cool. All right, now let's do sh add bytes. Ha! So so that's interesting to note. So LL is an alias command that gets read in at the time of the shell you opening a shell session to do an interactive shell session. So as a user, that's now, like for example, I open up this terminal and now I have an interactive shell session. I can do LL. But when you're running the shell script, you're actually working with the interpreter that lives on the computer. So I do which sh. This is the shell interpreter, that file, right? It's just like a gobbledygook file, binary file. That's the interpreter for the shell language, but it doesn't have LL defined in it. Right? That's something I defined in my own thing. So it's a. So this is where, when you're working with different shells, you got to define what's called a shebang. And so the shebang tells the shell script when you run it where do I feed this code to? What interpreter? So by default, it'll use whatever you tell it to here, like sh. Or if you try to run it like that, it might fail because it doesn't have a sh or zsh or any prior like leading command. It also doesn't have a shebang. So if you define the shebang and then you chmod the add bytes file to executable. Cool. So now that we have that, we can do. So it still doesn't know what it is, but anyway, that's just a kind of like a quick little.
One note is that when you're on different Linux distributions, some of them have aliases already built in. Like I know Ubuntu off the top of my head has LL, but let's say you're on Mac OS or you're on different Linux distributions, you might notice that some aliases are not there already. You have to define them yourself.
Bummer. I can't get it to work, but
You probably could source it very easy shell at the top.
it's a funky nuance with shell when you're adding variables because it reads everything as a string. So you have to tell it that it's actually a number. I think the expr utility is the way to do that potentially. Anyway,
Bryan, I was thinking about killing the stream here. Is there
Yeah,
anything
that
you
sounds
want to like go summarize, go forward?
yeah, I do a closeout. So yeah, thanks everybody that joined online. You can check out all this stuff and a lot more at this Unix repo. So Nonni/Unix on GitHub, and you can find me on Twitter at NonniIO if you have questions or want help or chat. I'm also on Telegram at the same handle. And yeah, thanks for joining, and have a great weekend.
Cool. Thanks, man. And broadcast.